Numbers, I can't remember. Right, you tell me which ones you had? 3 and 4. Right, does anyone need any bit of number 3 done?
Can you do part 4, please?
Part 4, yeah. Okay, so 3 part 4. So it says minus 2 root 2 minus root 2 I, and it said expressed in polar form. Okay, so the first thing you need to do is you need to draw. Right, actually you can get the modulus first.
Excuse me please, if a representative from Miss Ryan's 6th year PE class now could come to reception.
So remember, the modulus is the square root of a squared plus b squared, right, where a is the real bit, which is minus 2 to b squared, b is the number in front of the I, root 2 to b, sorry, it's minus root 2 to b squared. Okay, so that would be 4 plus 2, which would be square root of 6. Is that right? Square root of 6. Right, okay, then you draw. So it's across to minus 2 down to, so across to minus 2, which would be here, down minus root 2, okay, which would be there. So that's that. Connect it to the origin, and then make your right angle triangle. So the right angle triangle would be here. Okay, so I can find this angle here, but that's not the modulus. In order to get the modulus, what would I have to do with it? Or the argument even. Right, what would I have to do when I find the angle? Add it to 180, isn't it? So, drawing out the right angle triangle, this is x, right, this is, it's across 2 and it's down root 2. Do not take the minuses. Do not take the minuses, okay? So, then you do 10 of the angle. So 10 of x is opposite, which is root 2 over 2. That's not it won't be a whole number, right? So we'll round it up. We'll get it into the calculator, round it up to the nearest whole number. Do me. So what's the angle? 35 degrees. Right, lovely. Right, that is not the argument. That is this angle here. So in order to get the argument, you must add 180. So the argument is 180 plus 35, which is 215. Okay, so then in polar form, that would be r cos theta plus I sin theta. So r is root 6, cos of 215 plus I sin 215. Is that okay? Is that right? Any questions? Right, that's part 4, 3 part 4. Anything else from last night's homework? Have I done something wrong? Right, anything else from last night's homework? Anyone? Everything else was okay?
Can you do the second part of 4?
Second part of 4, yeah, no bother. Okay, so 4 part 2 is minus 2 all over minus root 3 plus I. Okay, you can't do anything with it in that form. You have to do the division before you start. So to do division, you multiply above and below by the conjugate of what's below. So that would be minus root 3 minus I. And you multiply underneath the line by the exact same thing, because if you don't, you're changing it. Okay, so above the line I have minus 2 into minus root 3 by minus I. Below the line I have minus root 3 plus I by minus root 3 minus I. Okay, so above the line multiply now. That's 2 root 3 plus 2I. Is that okay? Then below the line, minus root 3 by minus root 3 is plus 3. Right? I have minus root 3 by minus I, which is plus root 3I. I by minus root 3 is minus root 3I. And then I have plus I by minus I, which is minus I squared. The minute you see an I squared, so that would be minus 1. Okay, so above the line, that's 2 root 3 plus 2I. Below the line, that they cancel, and you end up with 3 plus 1, which is 4. Okay, so you can divide each one by 4, so that would be 2 root 3 over 4 plus 2I over 4, right, and they cancel down. 2 into 2 goes 1, so that's root 3 over 2, and this is I over 2. Agreed? Right, okay, so then you get the modulus and the argument of this complex number. Okay, so to get the modulus, right, okay, I'm going to draw there in a sec. Right, so to get the modulus, it's the square root of a squared plus b squared, which is root 3 over 2, 2b squared plus a half 2b squared. Into the calculator with that, that would be 3 over 4 plus, that's 1. Right, so the modulus of that is 1. Are we okay with that? Right, then a quick sketch, right, now it's not accurate, but it's across root 3 over 2, so it would be cross to root 3 over 2, and it would be up a half, right, so it's across root 3 over 2 and it's up a half, so there's that, there's the complex number. So join it to the origin, made a right angle triangle, right, so drawn out the right angle triangle. Okay, this side measures root 3 over 2 and this side measures a half, and I'm going to get this angle here, which is the modulus. Okay, so for the first time in a long time, the actual angle we're going calculating is the argument. I keep saying modulus is the argument. Is that okay? Right, because it's in the first quadrant. Okay, so tan of x is equal to opposite over adjacent, which is a half over root 3 over 2. Sort that out in your calculator. Okay, so that would be 1 over root 3. So then you get the inverse tan of 1 over root 3, and you would end up with 1 over root 3, 30 degrees. Okay, and remember, that is the actual argument, okay, for the first time in a long time. So in a, in a polar form, that's equal to cos of 30, 1 times cos of 30 plus I sine of 30. Is that okay? Are we okay with that? Right, okay. So now we learned, sorry, is there anything else from the homework? That was the last question, wasn't it? Okay, so now today, reasons why we would put it into polar form, right? Doodling, one of the reasons, and you needn't write this because this is not notes, this is me doodling. Okay, if it was in Cartesian form or rectangular form, right, if you were to multiply out, don't write this down, right, if you were to multiply two complex numbers, right, in Cartesian form, you'd split up the first bracket, write the second bracket down twice, yeah, plus 3i into 1 minus 2i, and then you'd get an I squared term and you'd replace it with minus 1, etc. Right? When the complex numbers are in polar form, it's way shorter to multiply them. Okay? So there's a bit of work in this. Then you have to go 2 minus 4i plus 3i minus 6i squared. Then you have to replace the I squared with a minus 1, and that would end up with 8 minus I would be your answer. Okay? Bit of work in that. Right? Okay? If the complex numbers are in polar form, and remember they can be expressed in both form, there's a shortcut to multiplying. There's also a shortcut to dividing. Right, so let's just write down the shortcut and then I'll explain what I mean. right? So what it means is, right, if the first complex number is written in the polar form, right, as in this is R1, the modulus of this by cos of theta 1 plus cos of plus I sine theta 1. This is the argument. And if Z2 is also written in polar form, right, okay, in order to multiply two numbers in polar form, you multiply the moduli by each other. So you multiply R1 multiplied by R2. So you multiply the moduli, right, but you add the angles, right, okay. So the answer is R1 multiplied by R2, the two moduli multiplied together, right, by cos of, you just add these two angles, and you add these two angles, right. So for example, in this example here, right, I want to get Z1, Z2, right. In order to do that, the rule is, in order to get Z1 multiplied by Z2, sorry, not point Z, multiplied by Z2, I just have a dot for the multiply, right, equals, you multiply the moduli, so 4 by 2 is 8, agreed, right, and then you add the angles, so 30 and 60 makes 90, right, plus I sine 30 and 60 makes 90, right, that's your answer, okay. And if they said give your answer in rectangular form, right, okay, you would just get the cos of 90. So the cos of 90 is 0. So that's 8 times 0. And the sine of 90, no, the cos of 90 is, 0. And the sine of 90 is 1. So that's 8 times I multiplied by 1. So multiply into the bracket, that would be 0 plus 8I. Or 8I if you like. Okay, just in case they tell you give your answer in rectangular form. If they said give your answer in polar form, that's your answer, right? If they said give your answer in rectangular or Cartesian form, you just, in your calculator, you get the cos of 90, and in your calculator, you get the sine of 90. Is that alright? Okay, are we good? Right, so a harder example, example 2. So simplify two times cos of pi over 9. No, I'll actually turn that into 20 degrees. I'll turn it back into degrees V plus I sine 20 degrees multiplied by, so dot for multiplied by 1/3 the cos of 20 plus I sine 20, and you can keep going across the line. I'll have to get a new line. Then it's multiplied by, so it's like three numbers multiplied by together, multiplied by, where am I? 6 times the cos of 20 again, plus I sine 20. Sorry, that's really bad, cos the bracket should be here. Cos of 20 plus I sine 20. And give your answer in A plus, in the form, give your answer in the form okay, so I'm multiplying three numbers here, three complex numbers in polar form. A lot easier multiplying them out in polar form than it is in rectangular form, isn't it? Right, okay, so all you have to do is do 2 multiplied by a third multiplied by 6. So 2 multiplied by a third multiplied by 6 is 4. Right, and then it's three numbers, so you add your three angles, 20, 40, 60. So cos of 60 plus I sine, add the angles, 20, 40, 60. Does everyone see how I did that? Okay, so you just multiply the three moduli, right? Okay, and then you add the angles. Is that right? Okay, and they said give your answer in the form a plus bi, so that's in rectangular form. So you actually get the cos of 60 on your calculator. So the cos of 60 on your calculator is a half. So that would be 4 into a half. And the sine of 60 would be, the sine of 60 is root 3 over 2. And then you multiply into the bracket by 4. So 4 times a half is 2. And 4 times that is 2 root 3 I. And that's your answer. Is that okay? Easy peasy? Yeah. We happy with that? Right, down. Can I go? Right, don't write down the next bit. This is just me explaining what I'm doing next.
Excuse me, please. Third years who have applied for the ski tour next year, please go to the chapel at 2:15 today. Thank you.
The excitement. You missed out. Damn COVID. Right, okay. But anyway, if you were to divide a complex number, so if you have 1 plus 3i divided by 2 plus 4i, now this isn't going to work out, so I'm not going to do it. I just made up these numbers. You multiply above and below by 2 minus 4i, agreed? Okay, agreed? That's what you do. And you'd have a lot of multiplying to do out on top and a lot of multiplying out to do in the bottom, wouldn't you? There's a bit of work in that, isn't there? Right, okay, so if you have it in a polar form, right, okay, so quotients is division, quotients is fractions or divisions, so quotients of complex numbers in polar form. So if you have z1 equal to that, and you want to divide them, so it's a lot easier to divide them in polar form. If you want to divide z1 divided by z2, right, all you do is you divide the moduli, so it's the modulus of the first one divided by the modulus of the second one. What do you think you do with the angles this time? If you added them to multiply, what do you think you do to divide them? Subtract them, yeah, so it's, there you go, that's what it is, okay. And I'll do the exact same angle, or I'll just do the exact same, I might just change that to 90, just to be different. And if you end up with a negative angle, that's okay too. I'll show you what they mean by a negative angle there in a minute.
This is in the log tables.
No, it's not in the log tables. This is not in the log tables. Okay, good question. No. Right, so for division, right, Z1 divided by Z2, all you have to do is, right, okay, divide the moduli. So 4 divided by 2, right, is 2, isn't it? 4 divided by 2 is 2. So will I just put in 4 divided by 2, right? And then you subtract the angles. So it's 90, take away 60, plus I times 90, I sine times 90, take away 60. So that would be 2 times the cos of 30 plus I sine of 30. And if they said, put it back into rectangular form, you get the sine of the cos of 30 and you get the sine of the whatever you call it. So that would be 2. And the cos of 30 is root 3 over 2. And the sine of 30 is a half. So that would be I times a half. Multiply in by 2. That would be root 3 plus 1i. Is that alright? Okay, that's only if they ask for it in rectangular form. If they didn't, you could leave it in polar form. Yeah, sorry. Apologies. Right, okay, so girls, sometimes when you do this, you might end up with a negative angle, right? So can I just explain what a negative angle is? We'll learn more about it when we do trigonometry, but just for the moment, it's okay to end up with a negative angle. That's perfectly fine. But what a negative angle is, I'm just going to explain what a negative angle means, because you know the way it could be 60 minus 90, you know, theta 1 might be 60 and theta 2 might be 90. So you might end up with a minus 30, right? Okay, so what a minus 30 is, girls, right? If we end up with a plus 30, right, that means it's here, right? You always go anti-clockwise from the positive x-axis, so that means the complex number is there. If you ended up with a minus 30 degrees, girls, that means you go clockwise. So the norm is to go anti-clockwise, as in to go this way to get the angle, right? If it's a minus 30, what they want me to do is they want me to go clockwise. So instead of going 30 degrees that direction, I would go 30 degrees this direction, in the clockwise direction. So the complex number would be down here. Okay, but it's perfectly acceptable to leave it as minus 30. Minus 30 just means when you're drawing the complex number, go 30 degrees in the clockwise direction as opposed to the anti-clockwise direction. Is that okay? So, like, if you wrote minus 30 and you wrote plus 330, that's the exact same angle, isn't it? The exact same position. Because minus 30 would be 30 in this direction, right? Plus 330 means go 330 around this direction. And the complex number is going to end up in the exact same position. Would you agree? So if I said an angle of 300 degrees, what would be another way of writing 300 degrees? Minus 60, wouldn't it? Minus 60. Right, so instead of going 300 around this way, go 60 in the other direction. You end up in the exact same position. Agreed? Right. If I said minus 40 degrees, that's another way of saying what? What would the plus angle of that be? 320, wouldn't it? Okay, so it's okay. My point is it's okay to end up at a negative angle. Don't bother changing it, okay? Because the angle is just to indicate the position of the complex number on the plane, right? So if it's negative, it just means go the opposite direction, go clockwise from the positive x-axis as opposed to going anti-clockwise. And if it's positive, you go anti-clockwise. Yes.
Are minus numbers only acceptable when like you have the usual way in which you go, like with complex numbers and stuff? You go
It's always anti-clockwise unless they tell you otherwise in maths.
So could you get minus angles in like different chapters? Or?
Yeah, we'll get them in trigonometry and stuff, but don't worry about it for the moment. Complex numbers is the issue we're dealing with now. Okay, have we got it? Right, okay, so you don't need to write that down, that's fine. Okay, right, I'm going to give you a couple of questions to do now before I move on. Right, okay, so I will blow these up and let's do numbers 4 and 5. Because I think it's, okay, I will blow it up, I promise. It's on page 31. Sorry, I need thicker glasses. Yeah, page 31, numbers 4 and 5. Okay, and it's on the board there if you want it. And I'm stopping the video because this will bring us to the end of class and then